Hello, my name is Rob Reynolds. Welcome to section 3.3. This is the continuation. Just wanted to finish up this video and talk about diminishing returns. For business calculus students, the point of diminishing returns is what we call the inflection point. And if you recall from my previous video, the inflection point can be found by the second derivative and looking at concavity and where concavity is changing. So if the second derivative testing that second derivative, not the second derivative test because that finds maxes and mins, but the second derivative, if the second derivative is greater than 0, then it's concave up, and then if it's the second derivative is less than 0, then it's concave down. And whenever you switch from concavity, then you found a point of inflection. So you can see this is concave up here, and this is concave down here. And you may think, well, I can just find this on the calculator, but the test will want exact answers, which include radicals, so no decimal approximation. So you do need to do this by hand to find maxes and mins and inflection points. So let me give you an example here. Remember, the point of diminishing returns, again, you guys know this because you're economics majors, but an increased investment beyond the point is considered poor capital. So I will show you an example here real quick. Let's find the first derivative, y prime. So let's see, this 3 times the negative 1/10 is negative 3/10 x squared plus 12x for this guy. And then the second derivative is negative 3/5 x plus 12. I'm going to set that second derivative equal to 0 to find the critical value. So I'll say 12 equals 3/5 x multiplied by 5/3. In order to cancel here and here, leaving with just x, and I get 20. So I am going to run this critical value by testing f double prime. Maybe 0 would be really easy to test, and then f double prime, just a big number. I don't know. I'll just try 30. So looking here, if I throw a 0 in here, I just get a 12, which is greater than 0, so I know this is concave up. And if I throw a 30 into the second derivative, this number is going to go pretty big, and that's going to go negative, and then this is concave down. So sure enough, I found a point of inflection, and it's at 20 comma something. I would just go back to the function and plug in the 20. So here's the author working it out. They get the 20 as well, and I think they have a nice picture. So right there, you can see it's really increasing, and then it's still increasing here, but this is the point where it's increasing not as quickly. So that's why it's called point of diminishing returns. And again, to find that y value, you would take the 20. Take this 20, the critical value, and plug it in, and evidently that's at the 20,000, because this is in terms of thousands. All right, so there's a couple other, if you go to Blackboard, and there's a couple other examples in here that I would encourage you to try to work through, finding intervals of concavity by looking at the second derivative and giving me some intervals. And then remember, if the second derivative is less than 0, it's down. If the second derivative is greater than 0, it's concave up. So a couple other examples. Here's where you're going to have to do the product rule. Again, throwing this into a chart, and then every time it changes, it's got point of inflection. I do want to talk to you about this is the second derivative test. Remember, we find the critical values from the first derivative, and we plug them into the second derivative. And if it's less than 0, we know it's concave down, and that creates a max. And then if it's greater than 0, concave up. Remember, that's like a cup. But that creates a min. It's kind of weird. I'm saying the word up and minimum at the same time, so that might be backwards of what you're doing. And then example number 12. I don't think these are on your handouts, but I would definitely go through those and make sure you understand the second derivative test. The last thing I want to kind of say is when you're using the second derivative test, you're finding actually maxes and mins. And on the test, and maybe even in the quiz, I know it's easy just to go to your graphing calculator and just go what second, calculate the either max or the min. I'll do the minimum here. By guessing to the left, I'll just type in a -5, press enter. I'll guess a 0, press enter, and -1, press enter. And sure enough, it just gives me the minimum. But notice it's in decimal form. So on WebAssign, when you take your test, they're going to want the exact answer, and you're going to have to type in that exact answer, and you may not recognize you know, what that radical value is. And you may not get a radical value, but let's see. So here's an example where the max is 6 squared roots of 3 for the y value. We're not going to be able to find that in your calculator. The only way to find that 6 squared roots of 3 is to take this x value and go back to the original function and plug in a 6. So let's see, here's the original function, and g at 6 would be 6 times the square root of 9 minus 6, and that's how they're getting 6 squared roots of 3. So remember, on WebAssign, they want the exact answer. Sometimes they're finding like the roots, like if the first derivative turns out to be, I don't know, something like x squared minus 2, and you have to set that equal to 0, you'll get x squared minus 2 equals 0 when x squared equals 2, and that's when x is equal to plus or minus the square root of 2. Well, don't go decimal. Actually use that positive square root of 2 comma something and a negative square root of 2 comma something. And so you're going to have to evaluate these radicals by plugging the radicals back into the function. So again, exact answers, and your calculator, if you guess left, guess right, guess on, to find these solutions are going to give you decimal approximations. So make sure you can do this by hand to be able to get these exact answers. If you have any questions, feel free to email me. Thanks.